Welcome in Tilco Advisors. We empower construction material manufacturers with cutting-edge digital solutions. And now, welcome to our podcast, where we share insights from the world of smart construction technologies.
We're here to cut through the noise and get straight to the competitive intelligence you need. Today, we're looking at something crucial for, well, anyone in construction, really. Manufacturers, engineers, BIM pros, you know the struggle. We're talking about that information black hole. You pour months, maybe years, into a rich BIM model packed with vital asset data. But then project handover happens. In our sources, they're saying up to, 95% of that crucial data just evaporates, it gets lost.
It's phenomenal, isn't it? 95%. The value just flatlines right at the point it should be taking off. And for manufacturers, this isn't just lost data, it's losing your competitive edge long term. Why pick your HVAC unit, your lighting, if its intelligence dies when the building opens?
Exactly. So that leads us to the big question for this deep dive.
Yeah.
What if those products, the actual physical bits, could talk back to the BIM model? What if they kept it updated? Real-time performance, health checks, how does that change things for competitiveness? Turning that static file into something alive.
Well, that transformation is exactly what's happening. It's where two huge forces meet. Building information, modeling BIM, and the Internet of Things, or IoT. So our mission today, let's explore how this integrated system through the digital twin gives you actual measurable gains. We're talking efficiency, cost, sustainability, and maybe just as important, let's talk about the real roadblocks. What's stopping everyone from jumping on this?
Okay, good plan. Let's start with the basics, the foundation, BIM. We mention it all the time, but let's just quickly recap. It's not just fancy 3D.
No, definitely not. That's the key thing to remember. BIM is fundamentally about creating and managing information digitally, right across the building's life. Think of it as a relational database. We often talk about dimensions. 3D is the geometry we see. 4D adds time scheduling, sequencing. 5D brings in cost. But for today, 6D is really relevant. That's sustainability, lifecycle performance. The model is basically built to handle rich data.
Right, so BIM is the structure, the database. Now, bring in the Internet of Things, the IoT, you called it the nervous system. What are these smart objects in construction?
Yeah, nervous system is a good way to put it. IoT is simply smart objects, sensors mostly, connected to the internet. They chat with each other, minimal human input needed. In our world, that means things like environmental sensors, air quality, temperature, proximity sensors for safety, RFID, tags tracking materials, GPS. And the tech is moving so fast. Sensors are getting tiny, lightweight, and crucially, way cheaper. We're seeing commercial sensors like the size of a Scrabble tile. Discrete, can run for 10 years on one battery.
Wow, okay. Scrabble tile size.
Yeah.
So you merge these two worlds. BIM gives the structure of the context. IoT provides the constant live feed.
Yeah.
And that creates the digital twin.
Precisely. The digital twin, or DT, that's the connection. It's a personalized model of a physical thing, but it's dynamic. It evolves. BIM gives you the starting point, the virtual as designed or maybe as built. But it's the IOP sensors feeding in real-time data, the telemetry, that keeps the model updated. It mirrors what's actually happening out there. Data assimilation, they call it.
That sounds like a serious step up. In terms of, the BIM maturity levels we talk about, where does this digital twin integration actually sit?
Oh, it pushes us right into the higher levels. BIM level 3. Connecting directly to sensors and machines, that operational IoT link, that's level 3B maturity. And when you get that seamless, secure, real-time data transfer, flowing that constant telemetry, you're hitting level 3C.
Okay, level 3B, 3C. Let's make it real. Give us some quick examples. What can a proper digital twin actually do for someone on the ground?
Right. The most obvious win is facilities management. Huge value there. Imagine, say, a chiller unit starts vibrating just slightly off spec, wear and tear. The IoT sensors pick it up instantly. The BIM model flags the performance dip against its expected parameters, and bang, an alert goes out before it fails catastrophically.
The check engine light idea, predictive, not reactive maintenance.
Exactly that. Saves a fortune in downtime and emergency repairs.
That's the building's health. What about people or the supply chain side?
Absolutely. Loads of applications take occupant tracking. There was a case study, the Charles Wright Museum. They used really discrete sensors on doors, CO2 monitors inside exhibits. Because they were so small, non-invasive, they got brilliant objective data, how people moved, where they lingered, all without, feeling watched. Great behavioral insights. And logistics, huge. A DET can simulate material flows in real time, track specific modules with RFID tags, forecast arrival times way more accurately, flag up risks before they hit the site, and cause delays.
Okay, that tees up the core issue perfectly. competitiveness,
Hmm.
especially for manufacturers and suppliers. It's cool tech, sure, but where's the measurable business advantage? You mentioned some striking data from Portuguese ornamental stone companies. What did they achieve?
Yeah, that case study is fantastic proof. These companies used industrial IoT, but in a really interesting network setup. They called it co-opetition. So they cooperated on things like sharing stock levels and resources, but still competed. And the results were measurable. Let's start with BIM 4D time management.
Time. In construction, that means reliability, hitting schedules. What happened to their on-time delivery?
Well, because they had better real-time communication and resource visibility across the whole network, their on-time delivery metric, they tracked it as KPIOTD, it shot up. Went from a baseline of about 67% reliability up to 77.5%. That's a solid 15.6% jump in just being reliably on schedule.
Yeah.
Huge for coordination.
Wow, 15.6%. That's significant. Fewer clashes for the main contractor, better reputation for the supplier.
Yeah.
Okay, what about BIM 5D, cost management?
Right. 5D is all about efficiency, especially labor costs, which are always a big factor. So these same stone companies tracked labor productivity, KPLP. They measured it in parts produced per worker. It went from 6.84 parts up to 8.72 parts per worker.
That sounds like a big leap.
It is. It's a massive 27.38% increase in productivity. They're making more faster at a lower cost without cutting corners on quality. That fundamentally boosts their competitive power.
Faster, more productive. What about greener? BIM 6D, sustainability. Construction has a huge footprint. Can smart data help there too?
It absolutely can, and they proved it. By optimizing how they used resources and managed production within that network, they got real environmental gains. They tracked CO2 equivalent emissions per part, KPI CO2 EQ, and they achieved a 21.8% reduction, dropped from 3.41 kilograms of CO2 per part down to 2.68.
21.8% less carbon per part. That's impressive. These metrics really show smart data isn't just a nice to have, it's a core part of hitting modern targets.
Exactly. It's a direct pathway.
But the immediate thought is often, this sounds expensive, big investment needed. Is this tech only for the mega projects, the giant firms? Or can smaller players get in on this?
That's such a critical point, because if it is only for the giants, it won't really shift the whole industry, will it? But we've seen research showing really low-cost ways in. For example, a system built just to monitor thermal comfort, pretty vital data if you're deciding on HVAC upgrades or retrofits, right? It was built using off-the-shelf stuff,
Yeah.
a Node MCU V3 board, a BMP280 sensor, common hardware.
Okay. And the cost for that circuit?
Get this, $15.57 USD total.
$15. Seriously. Cheaper than lunch.
Pretty much. And that little $15 setup gives you BIM Level 3B maturity for, say, a single-family home application, tracking temperature over time, feeding it back to the model.
So if the hardware, the sensor itself, is that cheap, where does the real challenge, the real cost, lie now? Is it shifting from the physical sensor to the software? It's the integration, getting that data into the BIM database meaningfully.
You've hit the nail on the head. That cost breakdown is key. The future spend isn't necessarily on the sensor gadgetry itself. That part's becoming democratized. The investment shifts towards interoperability, making different systems talk, designing the whole connected system properly, the analytics platform to make sense of the data stream. So yes, the $15 sensor proves access is widening, even small developments can gather performance data, but you still absolutely need the brain, the system, to understand and use that data effectively within BIM.
Right. That low hardware cost is encouraging. But we need to be realistic about the adoption hurdles. Despite these numbers, despite policy pushes like the EU's Data Act, BIM mandates, uptake is still kind of slow. Why is that?
Well, the construction industry's reputation, fair or not, is often one of being fragmented, maybe a bit conservative. That mindset creates real organizational barriers right away. What do firms say? High upfront costs for the integration, the training, a definite lack of tech know-how among existing staff, and crucially, you hear about business owners just being reluctant, hesitant to experiment, to disrupt workflows that, well, feel comfortable even if they're not optimal.
Okay, so there's mindset, cost, skills gaps. What about the tech itself? Even if a company wants to do it, what are the technical roadblocks they hit trying to build a proper digital twin?
The technical challenges usually revolve around data complexity and the underlying infrastructure. Interoperability is a huge one. Getting different software from different vendors to actually share data reliably is still a headache. Then there's just the complexity of designing these interconnected systems securely. And security and privacy themselves are massive concerns, obviously. You're dealing with constant real-time data streams. You have to get that right.
And infrastructure. Is it like trying to run a smart building on, I don't know, dial-up internet? Does legacy tech just kill the ambition?
Yeah, that's a good analogy. And the research backs it up. Inadequate infrastructure, old networks, incompatible systems is definitely a key technical barrier. But
Yeah.
here's the interesting finding. When researchers dug into what really drives the slow adoption, the biggest blockers weren't actually technical. The two strongest factors holding things back were identified as number one, a lack of governance and top management support, and then number two was inadequate infrastructure.
So it's fundamentally a leadership issue.
Ah,
A strategic commitment problem first, technology second.
That's what the data suggests. It's often a top-down failure to prioritize and invest strategically rather than just a bottom-up tech problem.
So fixing this needs more than just better sensors or cheaper cloud storage. It needs that strategic vision, clear governance, maybe smart policies to standardize things.
Exactly. The focus needs to be on secure data management. Some interesting work is looking at blockchain for data traceability, for instance, and policy is starting to catch up. Look at the EU's construction products regulation. It's evolving to specifically include smart construction products, and the digital product passport idea, linking the physical item directly to its digital performance data. That's becoming formalized.
This has been really illuminating. It really shows how BIM and IoT coming together isn't just additive, it creates something fundamentally new. BIM sets the stage, provides that rich context. IoT brings it to life with that constant data feed, turning the static model into, well, a living asset.
And the payoffs aren't just theoretical anymore. We're seeing hard numbers. The potential to be 15.6% faster on delivery, 27.38% more productive with labor, and 21.8% greener in terms of carbon output. For anyone making or specifying products or managing projects, those are the kinds of numbers that define who wins in the market going forward.
So here's the final thought we want to leave you with today. Maybe the biggest future value of BIM isn't actually during design or construction. Maybe the real competitive edge, the true digital twin value, kicks in after handover. Years later, when that constantly evolving data drives the next wave of efficiency, optimization, and improves long-term performance.
Yeah, it transforms the product from a one-off sale into a continuous source of valuable data, a completely different relationship.
That's it for today's episode. We hope you enjoyed exploring the world of smart construction and digital workflows with us. Don't forget to subscribe and join us next time for more insights into smarter construction.